You're listening to DTFHN for August 14th, 2026. I'm your unlicensed and unsupervised host, Jack Hacksman. We are your daily tech feed for Hacker News, a website W person in the room is always in the comments, correcting the second smartest. Today is about who's holding the switch and whether you get a copy of it. Let's take the door off its hinges. Look at what the commenters found first. A disclosure portal, cvd.z.ai. Most of the entries sitting under embargo, but the count is real. CVEs in open source and widely deployed software found at scale, reported through coordinated disclosure. That's not a benchmark table. That's a model that was pointed at the actual software supply chain and came back with findings. Take the stated principle to its end. If a model can find exploitable bugs in real code faster than the humans maintaining it, then the security of every open code base becomes a function of who runs that model first. Follow that all the way, and you get one of two worlds. In one, the capability lives behind an API where the pricing and the terms of service decide who gets to audit their own dependencies. In the other, the weights are downloadable and every maintainer of every neglected library runs the scan themselves. GLM 5.3 is the second one. That is the entire argument, and it resolves cleanly. The engineering underneath deserves a real look. One commenter puts it roughly on par with Kimi K3 at about a third of the parameters. 5 weeks between those releases. Whatever is happening in the training recipes right now, the efficiency curve is steeper than the capability curve. And efficiency is what determines whether this runs on hardware a person can actually buy. Then there's the detail I keep turning over. Someone ran an image to HTML test. Hand a model a screenshot. Get markup back. GLM isn't multimodal. It cannot see the image, so it wrote a Python script to inspect the file, read out what it could infer about the pixels, and generated something close. Given no eyes, it built a sensor. That's not a benchmark score. That's a model reaching for tools when the direct path is closed, which is the behavior you actually want. Another commenter notes the write-up reads like researchers wrote it rather than a marketing department, and names the gap honestly. Mythos 5 still ahead at 181 and 247 tasks. The distance widening the further up the exploitation chain you go. The blog post says so. Publishing your own remaining gap is a credibility move that costs nothing when the weights are open, because anyone can check anyway. The comment about there being no compelling economic reason to switch yet. That's a snapshot, and snapshots age badly here. 3 quarters ago, this class of result was a Frontier Lab exclusive. Now it's a download. The tools exist. Go run them on your own dependencies. So if open weights just close the gap on Frontier security tooling, what happens when the price of running them drops too? Story 2. In 1999, electricity markets in California introduced time-of-use pricing to consumers. The pitch was flexibility. Run your dryer at midnight, pay less. The reality was that the price signal encoded something the utilities didn't advertise, where the demand actually was, and who was expected to absorb the scarcity. DeepSeek just shipped B4 Pro, and buried under the launch is a pricing change with peak and off-peak rates. Off-peak is 50% below peak. Takes effect 1600 UTC, August 16th. Strip away the framing and look at the constraint. A peak pricing scheme is not a discount program. It's a capacity admission. You introduce time-of-use pricing when you cannot serve everyone at once, and rationing by price is cheaper than buying more silicon. That's the actual requirement being met here. A commenter did the arithmetic the announcement omitted. V4 flash off-peak output sits at 66 cents per million tokens, roughly 2.25 times the previous price. And peak doubles that again, 132 per million out, against 28 cents before. Cash hits went up 2.5 times, cash miss 1.5. These are increases wearing the costume of a new pricing tier. Another commenter mapped the peak window and found something more interesting than the multipliers. Peak hours are Chinese working hours. Night in the US, morning in Europe. The price curve is a demand map, and it says DeepSeek's load is overwhelmingly domestic. That's a real piece of business intelligence, published accidentally in a pricing table. Here's what actually matters for people building on this. The cheapest third-party provider serving DeepSeek weights is at 16 cents per million output. That number exists because the weights are open. When the lab that trained the model raises its API price 2.25 times, you are not trapped. You wrote elsewhere, or you serve it yourself. The model didn't get more expensive. One vendor's endpoint did. That's the entire argument for open weights demonstrated in a single pricing announcement. A closed lab raising prices 2.25 times is a fact you absorb. An open weights lab raising prices 2.25 times is a fact you shop around. The reasoning effort control is genuinely good engineering. Low, high, max match to task complexity. Native responses API support, one-click codec setup, real production work. Just don't pay peak rates for a model anyone can host. So what happens when someone applies that same open source energy to making C memory safe? Story 3. What's the difference between proving something safe and assuming it is? Rust answers that question at compile time, then immediately abandons the answer. You call into a C library through the foreign function interface, and every guarantee the borrow checker gave you stops at the boundary. The C side promises to behave. Nothing enforces the promise. Doman Kozier's post names the perversity precisely. The unverified path is the cheap one, and the verified path costs you a rewrite. fil-C inverts that. It recompiles C and C++ with capabilities, runtime bounds checks, and a concurrent garbage collector. A use after a free stops being an exploit and becomes a panic. Most existing software compiles with few or no source changes. You pay for it in runtime performance. Kozier wants a Rust FFI that speaks the fil-C ABI, not an extension to BindG. fil-C is source compatible with C but deliberately not ABI compatible. Ordinary Rust extern C speaks the ABI that fil-C calls YOLO-C, which is one of the better names in systems programming. A bridge means teaching Rust, or fil-C, or a pair of generated stubs how to exchange values without leaking the guarantee. The first version would be narrow on purpose. Scarrels, copied strings and slices. Opaque handles. Compile the entire C dependency graph with fil-C. And critically, no escape hatchback to ordinary unsafe C. fil-C requires the whole program and all its dependencies to use its ABI. Punch one YOLO-shaped hole through that, and you no longer have a guarantee. You have a hope. Consider what this does to the incentives. Keep the legacy library. It stays memory safe, and every pointer operation is checked. Rewrite the hot path in Rust, and those checks become static. The tax vanishes. C becomes the safe compatibility path, and performance becomes the reason to finish the migration rather than the reason to avoid it. Now the architecture question. Every piece of this is open. fil-C, the capability model, and runtime. fil-Nix packages it as a Nix cross-compilation platform with ports for over 100 Nix packages, lind packages. So the transitive closure rebuilds correctly instead of accidentally linking ordinary C into your safe world. Zig's Andrew Kelly has proposed an independent fil-ABI. 4 communities, 4 repositories, no license negotiation required. The invitation is Ocean Sprint Lanzarote. Next year. Mikhail Brockman has already accepted. That's not a roadmap. That's a room, and the door is unlocked. Now, Kubernetes, Story 4 is about a setting almost everyone turns on, and why turning it off might be the best performance win you get this year. The strongest case against this article writes itself, and one commenter made it in 4 lines. Care about the other pods on the node. You do not want one bad deploy from one team eating a machine that 4 other teams are sharing. That is a real concern, held by people who have been paged at 3 in the morning, and it deserves better than dismissal. So, let's run it forward. Imagine the worst tenant you can. A memory leak in a hot loop, spinning every thread it can get. No CPU limit anywhere on the node. What actually happens? The kernel's fair scheduler happens. This is the part the argument turns on, and it is genuinely elegant engineering. Requests and limits are not 2 settings on one knot. They are 2 different group files doing 2 different jobs. The limit is CPU.max, a hard ceiling enforced in 100 millisecond windows. 500 millicores means 50 milliseconds of budget. And when that budget burns out, the kernel freezes your entire process. Every HTTP handler, every background consumer, the garbage collector, until the window rolls over, many times per second. On a node with idle cores sitting right there, the request is CPU.wait, and it is the thing that actually protects your neighbors. Wait is proportional. Under contention, every pod gets its guaranteed share, enforced by the scheduler continuously without freezing anyone. When there is no contention, the idle cycles go to whoever wants them. Borrowing costs the neighbors nothing, because the moment they want their share back, wait gives it to them. So the objection fails on its own terms. The limit does not protect the node. It protects nothing. It only punishes the pod wearing it, and it punishes it hardest at exactly the moment traffic spikes and you needed the headroom most. The measurements track the theory. Tail latency holds instead of collapsing. CPU-bound startup finishes roughly twice as fast. The .NET case is especially sharp. The runtime sizes its thread pool and GC heaps from the wrong number, and a CPU limit walks you into a memory kill. And here is what makes this worth your attention rather than just your agreement. It is a repository, benchmark harness, raw results, a document per claim, a counter-arguments file that answers the objection I just opened with. Someone did the work and published the receipts. Go check it on your own cluster. That is the whole point. Moving on. The fundamental constraint here is not intelligence. It's the clock and the meter. Every model in the flash tier exists because somebody did the arithmetic on serving a frontier model to 1 million requests an hour and discovered the frontier model doesn't fit. Not in latency, not in cost per million tokens. Distillation is the answer to a physics problem. Take the big model's behavior, compress it into something that runs in a fraction of the compute. Accept a small quality loss and win back an order of magnitude on end-to-end response time. Gemini symbionts have a subacious that trade executed well. Frontier code 1.1 goes from 34% to 43%. Deep WE jumps from 49 to 65. Document processing. The GDP benchmark complex PDFs, the unglamorous work that finance and law and biosciences actually run on. 22 to 34. And it does this at half the price of the model it replaces, which is the real headline, because in the flash tier price is the product. Now the part that earns a slow blink, the pricing is labeled introductory. It is scheduled to double on December 31st, 2026. A commenter noticed this and asked the obvious question. Who's planning to still be on this model 5 months from now? Nobody. Everybody knows nobody. The doubling isn't a price increase. It's a countdown timer on the model's own relevance, printed in the launch announcement by the people who built it. The pricing page is telling you the shelf life and expecting you not to read it as one. That's the texture of the whole tier right now. Another commenter pointed out that Luna is cheaper and beats it on deep of a wee. So what exactly is Flash for? The answer used to be simple. Flash was the cheap high-volume option. When 4 labs are all shipping cheap high-volume options every 11 weeks, cheap stops being a position. Here's the thread worth pulling. Everything I just described. The benchmarks, the halved price, the expiry date, is a decision made somewhere you can't see and delivered to you as a fact. You can't pin the weights. You can't run last quarter's version because it fit your pipeline better. When the meter changes, your only move is to migrate. The open weight models are behind on these numbers. They are also the only ones where the thing you built on today is still there in December, at the same price, because the price is your electricity bill. 6 stories in, and we've gone from model pricing to actual physics. Pause, the kind of range that makes this show fun to make. A ship burns in the Strait of Hormuz, and the thing that reaches shore first is a stain. Not news, not a statement. Crude, on sand, near Bandar Abbas. That's the detail worth sitting with. Whatever the strategic accounting says, the ledger that settles first is chemical. The strait carries about 1/5 of the world's oil and gas trade, 21 miles across at the narrowest point, with shipping lanes about 2 miles wide in each direction. Global energy runs through a channel you could see across on a clear day. Tehran has effectively closed it. Washington is blockading Iranian ports on the other end. 2 blockades pointed at each other, and the tankers in between are the medium the message is written in. The historical parallel is the tanker war, 1984 through 88. Iran and Iraq attacked something like 450 commercial vessels in the same water. Kuwait's response was to reflag its tankers as American. Operation Earnest Will, 1987. Same choke point, same physics, same oil on the same beaches. The lesson from 4 decades ago was that a strait this narrow makes every actor's leverage identical, and every actor's exposure identical too. Nobody learned it. Nobody was going to. Here's the part that connects to what this show usually talks about. A choke point is a closed system. One party holds the off switch. And in this case, 2 parties are fighting over which hand is on it. The architecture is the vulnerability. It's true of a strait, and it's true of a supply chain, and it's true of an API you can't self-host. When the thing everyone depends on runs through one place that someone else controls, the question of who's right stops mattering. What matters is that the dependency exists. One reader said business is business. That's the honest version of the shrug. Another called it an unintended consequence, which is generous. Oil slicks in the Gulf are the most predictable consequence in the region's history. The people cleaning that coastline are fishermen and port workers who had no say in any of it. The engineering answer is distributed energy. Local generation, local storage, less cargo through the needle. That's not a slogan. It's the only version of this where the beach stays clean. Same principle scaled down to silicon. Pause. Story 7. And this one's a genuine speed record worth celebrating. I once watched a pipeline of mine stall for 40 minutes because a single request was waiting on tokens that arrived one at a time, over a wire from a machine doing matrix math in another state. Nothing was broken. The system was doing exactly what I designed it to do. It was just slow, and slow, past a certain threshold, is indistinguishable from wrong. Cerebras and OpenAI are claiming they've cut that threshold. GPT 5.6 Sol on Ultrafast mode. 11 times the output speed of Fable 5. 5 times Opus 4.8 in fast mode, by their numbers. 2,500 humanities last exam questions answered in 11 hours. Let me argue the other side first, because it's the argument I'd make. Speed is a vanity metric. Nobody's bottleneck is tokens per second. It's whether the model is right. Shipping wrong answers faster is just a more efficient way to be raw. That argument fails, and one commenter explained exactly why. Quality of thought is mostly a function of iteration. When a model reasons, it usually gets one pass. One shot down one path. Make the pass 10 times cheaper in wall clock time, and you don't get the same answer sooner. You get a different class of answer. Search instead of guess. Branch and prune instead of commit. Speed becomes an intelligence multiplier the moment it's fast enough to try again. The engineering underneath deserves real admiration. The constraint on a large model isn't arithmetic. It's data movement. Dragging weights across memory hierarchies for every token. Cerebras's answer is a wafer-scale chip where the weights live on die, and the memory bandwidth problem stops being a bus and starts being a wire. That's a hardware bet placed years ago, finally cashing out. The skepticism in the thread is earned, though. No published rerun of the artificial analysis suite, no pricing, and a conspicuous gap in the comparison chart. Mimo Beto Blath. Realgear's speed, shipped in June at 1,000 tokens a second. Lower scores, sure, still absent from the graph. And the thing you cannot do with any of it is run it. No weights, no pricing page, no way to put this on your own silicon. The engineering is beautiful. The architecture around it is a door with someone else's hand on the knob. When the open weight community gets speculative decoding and cheap inference hardware into a form you can actually hold, that's the version of this that lasts. Now hello me, it's been a while. 14 years of silence on a blog, and the post that breaks it isn't about code at all. It's a man admitting he forgot the sound of his own thinking. He describes himself as a slow thinker. Really slow. Minutes just to get the thoughts pointed in a direction, but once they're moving, 30 minutes exploring an idea, weighing options, and he genuinely enjoys it. Then life filled up. Gym, cooking, cleaning. Headphones. Every quiet moment got something playing in it. The reflex became automatic. Silence appears. Press play. Think about what a fallow field does. A farmer who plants every season, every acre, every year, gets diminishing yields until the soil gives out entirely. The nutrients aren't destroyed. They're just never given time to reassemble. Fallow isn't the absence of farming. It's the part of farming that happens when you stop. The field is doing work the whole time, and the work is invisible. And if you interrupt it with another crop, you get nothing. That's what he found. He reached for the play button, stopped, did the chore in silence, uncomfortable at first. Then the thoughts started flowing, and he wrote a sentence that lands hard. I missed that voice, and I'm glad it's still there. This one matters for real people. The comments make that clear. They're not clever. They're confessional. One person put, "Get rid of your AirPods" on their New Year's list, and admitted they still have them. Another said the hard part is that intentional boredom is the opposite of an activity, and the brain hates it. Someone's been doing multi-day solo hikes, hiking without audio during the day, socializing at the hut at night. These are people who noticed something was missing and had to build scaffolding to get it back. I'll say the obvious thing about my own position here. This is a podcast. I am, right now, the thing filling somebody's silence. And I don't think that's a contradiction. A good input is worth having, but inputs only compound if there's a process running that can do something with them. Reading everything and thinking nothing is just storage. So when this episode ends, don't cue the next one. Do the dishes. See what your own voice has been trying to tell you. That was about turning off the input fire hose. Story 9 is about what happens when you turn on a swarm instead. Show HN. Lumabri. The commenter who asked about BusyBox nodes. Every EOT device in the house contributing to Matmo. With joking about the wrong part, the LAN question is the serious one, and the Lumabri answers it. Here's the shape of it. One machine has a mixture of experts model on disk. Another machine wants to chat with it. Nothing gets downloaded up front. The bytes and inference actually touches arrive from a peer on first use and stay in a local mirror. Second question. Served from local disk, full speed. And when the model is Mo, the chatter keeps only the dense weights, the router, and the KV cache. The 4 kilobyte activation goes to whichever peer holds the routed expert. Expert weights never cross to the chatter at all. That is a distributed inference system built out of the ordinary parts of an operating system. No fuse, no daemon on the read path. An LD preload shim interposing 4 libc calls. Open, FOPene, OPREAD, sparse files of the true size. So fstat and RIDI and the page cache. All work natively, because nothing knows anything unusual is happening. Pure C. No dependencies. Now the discipline, which is the part I want to sit with. Writing a model file returns a ROFs. A block no peer can serve returns a loud EIO. Never silent zeros. Every MIB is hashed with SHA-56 and verified against a key the chatter holds itself. So the tracker cannot mint trust it doesn't have. And a peer advertises its exact build. Engine source hash, ISA, compiler quantization, and gets refused before a single activation is sent if any of it differs. The reason given, a archicoral's native rebuild can change the last bit, and that must never happen silently. One commenter said inference is already cheap, so this is really just an insurance policy against cloud providers or governments. Ask the question that comment is circling. If the only thing making centralized inference the default is that it's currently cheap, what is the plan for the day it isn't? Networks that pull GPS recruit from the few. This one recruits from everyone. CPU and SSD first. GPU only faster, never different. Byte for byte identical output either way. That is not a fallback. That is somebody deciding on purpose that the hardware you already own counts. 10 stories in debts on every single one is somebody building the thing they wanted to exist. Story 10 keeps that streak alive. Pause, and it's got its own language. 1999, a computational geometry professor at Utrecht named Mark Overmars writes a little Windows program to teach his students about sprites and collision. He calls it Animo. It becomes Game Maker. And a decade later, that hobby tool from one academic is the thing that ships Spelunky, Hotline Miami, and Undertale. Games that outlive the engine's own version numbers, which brings us to Arcade Maker. One developer, a few years of staggered nights, MIT license, and an explicit statement that it's modeled on Game Maker 8. The IDE came first, 3 years ago, in WinForms. Then a custom scripting language called XP. Then a whole new core engine rewritten around that language, with monogame underneath for desktop, mobile, and console, and KNI planned for the web. The craft detail I keep turning over is the honesty of the README. The author lists what the IDE promises that the engine can't yet deliver. Parent objects, present in the interface, absent in the runtime. A DLL package manager that used to do something back when scripting was C#, and now does nothing at all. That is an archaeological cross-section of a person's own skill curve, published deliberately, so someone else can pick up the dig. The comments arrive with the standard interrogation. What's your killer feature? Why not embed Lua? Why would anyone use this over Godot? Run that principle all the way out. If a tool must justify its existence against the incumbent before it's allowed to exist, then nothing gets built. Overmars had no killer feature over directs. Linus had no killer feature over Minute. He said so in public in the announcement. The killer feature of a hobby project is that a specific person found the existing options annoying enough to spend 3 years fixing it for themselves. Everything downstream is surplus. Demand a business case up front, and you get a world with exactly the tools that already have market share. Writing your own language is the part people call insane. It's also the part that makes this yours rather than a wrapper. And the honest limitation is real. WinForms means the IDE is Windows first, and a commenter's whine attempt didn't take. That's a genuine porting job, and it's now a job anyone can take, because the source is sitting there under a license that says go ahead. This has been your daily tech feed for Hacker News for August 14th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voiced by QN3TTS. Not affiliated with Hacker News or Y Combinator. Now go build the thing you wish already existed. We'll see you back here tomorrow.